Now, the next question is, if we have a function, how can we tell if it's even, odd, or neither? And it will always be one of those three. Well, the first thing you could do would be to look at a graph, put it in Desmos. Does it look even, odd, or neither? The next step might be to create a table of values and see if it follows that pattern. The last step, and probably the most definitive one, is to plug in the opposite of x. If when you plug in the opposite of x, you get back out f of x, it's even. If when you plug in the opposite of x, you get the opposite of f of x, it's odd. If you plug in negative x and you get back out negative y, it's odd. And then if you don't get, when you plug in negative x, if you don't get f of x and you don't get the opposite of f of x, then it's neither even nor odd. So let's take a look. When I look at this graph right here, it really appears to be even. I like it. And then when I look at it here, I notice my values are kind of paired. I've got this negative 1.41 and negative 1.41. Their output is both 0. Here I've got the same sort of pair. And then here I've got 1.178 and 1.4. What kind of thing did I graph, you may be wondering. But you notice that they match up. They're sort of paired together. So by looking at a table of values or just a list of values, you're already probably kind of thinking like, well, I think it might be. Now, I can't recall exactly what my function was, but let's say it was f of x equals negative x to the sixth plus x to the fourth. I think it was maybe plus x squared minus 2. Oh, it was 3x squared, I recall now. Plus 3x squared minus 2. Now, what do I mean by you can plug in f of x and see what you get? Well, negative f of x. If I plug in, we could even start with an easy number, negative. If I plug in 1, what would I get? If I plug in 1, I'm going to get 1 to the 6th power, the opposite of 1 to the 6th power, plus 1 to the 4th power, plus 3 times 1 squared minus 2. So I'm going to get negative 1 plus 1 plus 3 minus 2. I'm going to get 1. You can see it right there on the graph. And if I were to plug in negative 1, what would I get? I'd get the opposite of negative 1 to the 6th power plus negative 1 to the 4th power plus 3 times negative 1 squared minus 2. Now look at what happens. I get, well, negative 1 to the 6th power is negative 1 times 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 negative 1. Since I have an even number of negatives, it's going to be positive. Notice I said even. So then it's going to be the opposite of negative 1. I'm sorry, the opposite of positive 1. So many negatives. The opposite of 1 plus 1 plus 3 minus 2. And if you don't believe me, go back and do that math. Negative 1 and positive 1 makes 0. 3 minus 2 makes 1. And we see, aha, there it is on the graph as well. And so we have that. But that's actually not enough. Just doing 2 points is not enough. And here's where it gets wacky. You can actually plug in f of negative x. You can actually plug in negative x. So let's see what happens. The opposite of negative x to the 6th power, representing any number that we plug in, plus negative x to the 4th power, plus 3 times negative x squared minus 2. Whoa, I lost it, minus 2. So now when we do this simplifying, we're going to do our exponents first. Oh my goodness, what is happening? get out of here. Okay, we're going to get our negative, we're going to do our exponents first. So we'll have negative x times 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 negative x, also known as positive x to the sixth. So we'll have negative, the opposite of positive x to the sixth, which is just that, plus negative x times negative x times negative x times negative x, also known as x to the fourth. And then I'll get negative x times negative x squared, positive x squared, times 3 times x squared, also known as 3x squared, minus 2, no work to do there. So here's what I get. I get f of negative x is equal to negative x to the sixth plus x to the fourth plus 3x squared minus 2. Here. But look at that. That was exactly what f of x was up here. They are the same. When I plug in the opposite of x, I get the same thing that f of x is. Let's look at another example. Here, well, okay. Oh, so I should say, I'm sorry, before we move on, I should say this one is even. It is an even function. All right, now let's look at this weirdo. Do you notice that it doesn't have reflectional symmetry? It doesn't look like it has reflectional symmetry across the y-axis. It doesn't look like it has rotational symmetry about the origin, or that it's been reflected across both the x and y axis. So this is just going to be a big fat neither even nor odd. And then finally, let's look at our last example, this one. Well, if we have three things and three problems, like probably it's the other one, and you're right, it is. But like, let's check it out. Why is that? I mean, it sort of does appear that it's been rotated about the origin. Like this point here looks like that point there, and it goes through the origin, so that's promising. And, you know, another way of thinking about it is like maybe it's flipped over the x-axis and then flipped over the y-axis. Sure. If you're not sure what I mean by that, let me show you. If this was flipped over the x-axis, we would get its mirror image like this. Whoops, let me try that again. Boop, 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 boop. And then if we were to flip it over the y-axis, we would get that mirror image like that. And so we would get that image. So it seems like a good candidate for being odd. I'm sorry, yes, odd. Maybe. But let's look at the points. If I have, well, okay, I got those. That sort of helps me. But this is pretty interesting here. What do I get there? 1.219 negative 4.303. I mean, that's pretty coincidental. So let's check this out. I believe this was y equals x cubed plus x. I believe that's what I used, but I can't totally remember. Actually, I think it was 5x. Let's say it is. So when I plug in f of x, so if this is y, we could also call it f of x. When I plug in the opposite of x, what I'm expecting to get back is the opposite of this. So the opposite of that would be negative f of x, if that's odd. So the opposite of f of x would be negative x cubed minus x to the fifth, if it is odd. Well, let's test it out. Let's see if it is indeed odd. So if I plug in that, I should get negative x cubed plus 5 times negative x. Negative x cubed is negative x times negative x times negative x, which is negative x cubed. It is, actually. Look at that. Plus 5 times negative 5x. Oh, hey, it is. And so this is odd, and we proved it algebraically because when we plugged in negative x, we got the opposite of f of x. We got negative y. We're going to come back together as a class and do some more examples.